We're now going to put everything together in order to write the equation of a line in general form, as well as to produce the graph. The reason we use general form is because it's the fancy form, but also no matter what point you might happen to choose on the graph, as soon as we convert into general form, everybody will get the same answer. Because we can never begin in general form, that leaves us with slope-point form or slope-intercept form. Slope-intercept form will only work if you're given the y-intercept. Most of the time you need to begin with slope-point form. So always, we need two pieces of information, and we're going to take those two pieces of information to get a slope and a point. And we're actually going to write down what is our slope, what is our point, and then from there we can get the equation. Now we know that we can calculate the slope if we're given any 2 points on a graph. So I'm going to calculate the slope first of all, and then because in this particular question I'm given the y-intercept, I can start with that y equals mx plus b. So my y-intercept is the b value, and this is my slope, the value of m. Now to go into general form, I need a positive x, so right now x is negative, so I'm going to bring that over, y is staying put, and then the 2 also is going to come over to that side, and then I need to eliminate any fractions or decimals. So because I'm dividing by 3 here, I'm going to multiply every term by 3 to keep it balanced, and then this is the general form. I can graph this by plotting the 2 points and then connecting them. And then we're also going to check a couple of things. First of all, we know general form is a quick way to get those intercepts. So let's try this. If I'm looking for my y-intercept, x is 0. So imagine that's crossed out. We're going to move this over. My y-intercept is going to be positive 6 divided by 3. Positive 6 divided by 3 is 2, so that's good. To get my x-intercept, y is going to be 0. So if we imagine a 0 goes there, that term is gone. My x-intercept is going to be positive 6. So quickly check if everything jives together. In order to come up with the equation of the line, we need a point, which is given to us, and we need a slope. Now, in this particular question, we're told that our line is going to be perpendicular to this line. So the only thing that we can get from this is the slope. We know that if lines are perpendicular, the slopes are negative reciprocals. In order to get the slope from general form, we're going to rearrange it into slope-intercept form. So because I have a -1 coefficient, I'm going to move this y over, so it becomes a positive y, mx plus b. M is my slope, so the slope on this line happens to be 4. Now, our line is perpendicular to that, so we need to take the negative reciprocal of that, and the slope that we're going to use is going to be this one. My point is not a y-intercept, so I have to begin in slope-point form, which I can then convert into general form. Make sure that you clearly identify what is the point and what is the slope that we're using. Now we have to begin with slope-point form. Y minus the y-coordinate is equal to the slope times x minus the x-coordinate. We're going to distribute in to get rid of the brackets, and then we're going to look at our x term. So this is a -1/4, so the x needs to come over here, making it positive 1/4. The y is not moving, and then I'm going to subtract 5/4 from the other term over here, its like term. Now, when we do this, remember we need a common denominator, so the common denominator would be 4/4. -4 minus 5 is -9. The denominator stays the same when you subtract fractions. Now, x is positive. We're going to eliminate the denominators, and we have general form. Now, when you go to check this, we know that in general form, an x-intercept occurs when y is 0. So if we zero this out, I have an x-intercept, move this over at positive 9, and then check the graph. Is that what we're going to have? We know we have a y-intercept when x is 0, so zero this out. Our y-intercept occurs at 9/4, which is 2 and a little bit, 2 1/4. So check, does that work? On the graph, always start with the information given. So we know we have to go through 5, 1. That's the first thing I would do, is I would plot 5, 1, and then I would go down 1 over 4 or up 1, 4 to the left, and then check to make sure does all the information together work. And in our last one, the equation of the line that we have to produce has the same x-intercept as this line and is parallel to this line. So we know we need to get the slope from here. They're going to be equal if the lines are parallel. And we also need to get the point from here. We know an x-intercept occurs when y is 0. So if we put a 0 in here, can we solve for x to get that point? Clearly identify what is the point and what is the slope that we are going to use. The x-intercept occurs when y is 0. So I've substituted 0 in and then solved for x. So we're going to use a point of 3, 0. And if my slope is parallel to this line, That tells me the slopes are the same. I'm going to put this into y equals mx plus b form, and then this is the slope. My lines are parallel. Slope on our line is going to be the same. And that's the only piece of information we get from there. Be really careful. We're not doing anything with the y-intercept here. Our line is parallel to that, but that's it. We do not have the same y-intercept, so don't worry about that. We're just getting the slope from there. And then because this is the x-intercept, you also have to be really careful. You cannot use y equals mx plus b if you're given the x-intercept. It only works for the y-intercept. If you have the x-intercept, you have to start with slope point form. Y minus the y-coordinate is equal to the slope times x minus the x-coordinate. We're going to rearrange this to get rid of the brackets. My x is positive, so everything comes over here. So I'm going to move the y over, making that y negative. This is not moving. The sign doesn't change on the constant term. To eliminate this 3, multiply every term by 3, and we're going to get the general form. And then you're going to check a couple things. So I would go with the information originally given to us. We know that our line has an x-intercept of 3. So I'm going to plot that point, and I'm going to use this slope. Up 2 over 3, up 2 over 3, etc. Now let's check. In general form, if we're looking for the x-intercept, 0 out the y, so that's gone. We should have an x-intercept at positive 6 divided by 2 is 3. Now check the graph. Do we have an x-intercept of 3? Is it matching what we should have? We have a y-intercept when x is 0. So 0 this out. I have a y-intercept at 6 divided by negative 3, which is negative 2. Check. Do we have a y-intercept there at negative 2? Notice, that's a different y-intercept than this line because those two lines are parallel. They're not the same. Be really careful. The only information you pull from here is the slope. The only information you pull from here is the x-intercept. That's it. And then you also really have to watch. If this is the x-intercept, then you have to begin in slope point form. And one final piece of advice for you. Remember that a horizontal line and a vertical line both have one intercept. So one intercept, one variable in the equation. One intercept, one variable in the equation. If you see only y equals, there's no x in there, that tells you we have a horizontal line. If you see only x equals, no y in there, that tells you we have a vertical line. So the easiest way to get the information from here is to quickly draw yourself a sketch. We know all horizontal lines begin with y equals. We are crossing the y-axis at 5, so we're looking at that y-coordinate. We know all vertical lines begin with x equals. We're crossing the x-axis at negative 2, so it's that x-coordinate that we want.